Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and WhiteSource. My name is Cody J. Brown. I'm the host of TechStrong Learning. We have an exciting presentation ahead, but first I have a few housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion, the on-demand version will be made available shortly after we conclude the webinar today. If you have any questions, we want you to go ahead and submit those to the Q&A section on the right side of your screen. And for any additional comments, or you just want to let us know from where you're tuning in, go ahead and use the chat tab. Finally, at the conclusion of our webinar, we will have a drawing for 4 $25 Amazon gift cards, so stick around to see if you're one of our winners. So on to our topic today. It is bad actors are targeting NPMs, how to protect your supply chain. And I'm joined today by Maciej Minsfeld, Senior Product Manager Supply Chain Security at WhiteSource. It is my pleasure to turn the floor over to Maciej at this point in time to get us started. Thank you so much for being here with us today.
Thank you, Cody, for this amazing introduction. Hey guys, hello everyone. Today we're going to talk about bad actors targeting NPM, and we're going to talk about protecting your open source supply chain. So let's start it. Aside from Cody, what Cody said a bit about me, I'm Maciej. I'm the creator of WhiteSource Diffend. I'm a senior product manager at WhiteSource. I'm heavily involved in the Ruby ecosystem and Ruby ecosystem security. I love open source. And last year, I've reported over 1,300 packages to NPM, malicious packages. And this year, we're at the end of February, it's over 500 packages that I reported to NPM. Me and my colleagues, based on our research and our findings. So today we're going to talk a bit about what are package registries, just for people that don't know or just, run a command and expect things to happen. We're going to talk about some of the attacks and risks associated with them. And we're going to talk about countermeasures that you can take to minimize, I don't want to say to remove, but minimize the risk of being compromised. I hope to leave you with a bit of knowledge on how to mitigate certain problems, and I hope to leave you with an awareness that package management shouldn't be taken lightly, that you shouldn't go with this trust by default approach to open source supply chain in general, to open source libraries that you and your colleagues are using when doing software development. And yeah, I just hope you get something cool out of this presentation. It's worth pointing out that 60 to 80% of an average application code base is comprised of open source. We introduce more and more abstraction layers that allow us to do more and more stuff and develop applications faster, but we rely more and more on open source components built by people we don't know. And to me, it's just blocks on top of other blocks, combining blocks to achieve something. And one of the most critical components when talking about open source, and especially in the context of open source supply chain security, are package registries. Package registries are places where you can host your open source software, and places from which you can allow other people to use them. Some people share open source software on GitHub or GitLab on any other places like that. But in the end, people most of the time use the registries like NPM, RubyGems, PyPy, and others to put the final product, which is a package, with a bundle of software that they want to share with you. And one more thing that is really important aside of package registries is package registries clients. When I talk with people, they quite often don't see the difference because for NPM, they're named the same. You have NPM, the registry, you have NPM, the client. For Ruby gems, that's actually Ruby gems and bundler. But even for NPM, you have things like yarn or PNPM, alternative package registries clients. So they're often called package managers as well. It's a piece of software that allows you to automate the process of installing, upgrading, configuring, removing, or running open source components. And package registries clients, when they want to download something, they ask package registries for this data. And you use it. The usage of it is really simple. You have your proprietary code, you have your package registry client, you define your dependencies. Those can come from public registries or private registries. And the package registry client is just supposed to figure things out. You can define certain versions of the open source components in which you're interested, or you can leave it open to get the most recent ones most of the time. And if there are many transitive dependencies, package registry clients are supposed to make sure that the combination of all of the dependencies can work with each other. This is how it is supposed to work in theory. Today we're going to talk mostly about NPM. NPM is a primary package registry for JavaScript ecosystem. And most of the things I'm going to talk today about come from us, WhiteSource, looking at this registry, looking at the packages that are being published there, and doing our best to defend not only our customers, but also the whole ecosystem from malicious actors. NPM is the biggest package registry there is. It's several times bigger than Ruby gems or Maven or any other. It has almost 2 million packages with over 23 million of versions, and it has around 40 billion downloads per week, which gives us almost 70,000 downloads per second. And that's a pretty neat number, if you would ask me. Because of how popular it is a great place for attackers to be. And today I'm gonna give you a couple examples of attack vectors, how malicious actors, you shouldn't do it, but how malicious actors target NPM, and then we're gonna talk about countermeasures. So I picked a couple interesting examples. They present different attack vectors, and I hope you learn something cool. We're gonna start with an imposter library method. That's a method that aims to trick a user into thinking they're using a legit package that provides certain functionalities that you can use because it was published by a company. And once you install a package like that, it can either stay there and do nothing bad, or it can contain malicious code, or malicious code can be released in future releases. So attackers can use packages that seem to be legit, that actually contain a legit business logic, to gain a decent user base, and only then to exploit the fact that they own the package. It's not only a theoretical problem. It happened in a Ruby gems ecosystem last year with a package called ddtracer. And I've seen similar cases happening in NPM at the beginning of this year, where a package would be released that would claim, and it would provide certain functionalities, but then alongside, in one of the releases, not in the first one, it would contain some malicious code. But this example is the best one because it was crafted really nicely. And it mimicked the Datadog client. It had no malicious code at the moment of release, but it was mimicking the ddtrace Datadog owned package versioning schema. It would refer to Datadog source code. It would refer to their GitHub stars. All of the things would say, I'm DDTrace, I'm owned by Datadog. And I was mistaken by that. We pinpointed that for manual inspection. I was like, yeah, it looks good. It looks good. But then I just started looking, okay, why would we have a false positive like that? And it clicked. It wasn't what it claimed to be. So we detected that. We contacted RubyGems, we contacted Datadog, and we figured out it's a build-up for a bigger attack. But something similar happened with GrabHub company. There was a package called GrabHub Cookbook that would steal your environment variables, all of them, the moment you would install it. And it also, you could be mistaken that it was published by GrabHub because of the namespace, right? The second interesting thing you can use, aside from trying to confuse developers, is elevating bugs in how private registries or registry clients resolve dependencies. Just for people that don't know, I'll explain what transitive dependencies are. It's super simple. Transitive dependencies are just dependencies of your dependencies, or dependencies of your dependencies, and so on. You can have a lot of them, especially if you look into your node modules directory. What is worth keeping in mind is that understanding and resolving dependency tree is not easy. The resolution engine needs to make sure that all of the versions of all of the packages can work together, and that there are no restrictions that would block any of the packages from being used because of a version conflict and things like that. For example, one of your packages could require a first version of a package, and a different one would require a third one, right? So then you would have a conflict, and the package registry client, the resolution engine in it, needs to balance those and make sure that everything is supposed to work as expected. It gets even more complicated if you have multiple sources of packages. So there's more and more proprietary software that uses other proprietary dependencies, may it be built by the same company or just commercial software that you bundle into your applications. Resolution of their transitive dependencies, especially if a proprietary software uses public packages, may introduce bugs. And if there's a bug in the resolution engine, it may end up that instead of getting a private dependency coming from a private registry, you're getting a public dependency with the same name, but with a higher version. And this is what happened at the end of 2020. Alex Birsan did amazing research. What is worth pointing out, we at Diffend, we detected that, and we did report that to other RubyGems security team members, and we made a decision to allow those packages to be there. So Alex shouldn't say he hacked into certain companies using RubyGems. He was allowed to do that, though he elevated bugs in bundle resolution engine and NPM really well. So kudos for that. What you need to remember about dependency confusion is that it can happen without you taking any actions. You don't have to redefine things. You don't have to bump them. There's certain cases with Yarn, for example, where Yarn, with resolving dependencies, may make a mistake, especially in older versions. And then if there's a package with the same name in a private and a public registry, it may install the public one, which may contain a malicious code. There are a couple companies researching open source components available in package registries. And what is quite interesting is that there are legit security researchers that indicate and describe really well their packages, saying, oh, it's a security research, you can contact me here and there. It isn't collecting any sensitive data and so on. But there are also people claiming they are security researchers while they actually inject things like Bitcoin miners, remote code execution stuff, and things like that. It's not a research, but the reason why they claim they're security researchers is for people like us to, or people in NPM, for example, when they security people in NPM, to just look at it and say, okay, it's a harmless security research. The company that they're researching has a public bug bounty program, so maybe we could keep this package up and running. And some bad actors figured out that they can say they do that while actually doing other things. We did report 61 packages like that from NPM. Another really interesting problem is something we call dependency content replacement. So in general, when you look at open source software components, packages, they're supposed to be immutable. What that means is that, at least for the most popular package registries, when a package version is released, let's say 1.0.0, its content cannot change over time, right? So you can remove it from the registry and you can upload 1.0.1. But the 1.0.0 shouldn't change, which means that if you install it today, the content is going to be the same as if you install it in a week or in a month. Unfortunately, that's not entirely true with NPM. So a typical case of dependency content replacement would be with packages that define that their dependencies and their transitive dependencies, and one of those refers a GitHub dependency. So NPM, when you define a package JSON, it allows you to define, in a quite sneaky way, a dependency on a GitHub repository instead of a dependency on a NPM package, right? So it creates a chain where one of the links is mutable. And what is challenging with this is that if you pick a package like this, even with all of those dependencies and all of those GitHub dependencies, and you analyze that, you may not see anything problematic or harmful, right? It's okay. We checked it at 10 a.m. Monday. Looks good. It's fine to use it. But then suddenly the next day, or in a couple days, or in a couple weeks, the GitHub content may be changed. Someone may have, and it actually happened. It actually happened this year. I cannot give you the company name, but it did happen, where one of the links, one of the transitive dependencies that was defined on GitHub was changed into malicious code, and this malicious code would contain a remote shell with which attacker could do pretty much anything with the instance that he compromised. It's a really challenging one because you basically lose this warranty of immutability. Whatever you install today and whatever you install in 5 days, in a week, in 30 seconds, it may not be the same. And that is a really big problem. Just to be clear, it may happen with other externally linked resources. It's not only about GitHub. I just provided GitHub as an example. It may be some files downloaded from an S3 bucket, from a harmless FTP server. It may be anything that isn't tightly locked either to a version of a different package or to a SHA-1 checksum of the content. If it's not locked, it can be changed. If it can be changed, it can be tampered with. If it can be tampered with, it can be used to build up a complex open source supply chain attack. And we've seen it happen a couple times this year already. And for me, it's something new. It's a more complex attack that is. It isn't. You don't get instant gratification. It takes sometimes weeks to build that up. But when it happens, it's much harder to detect things like that. There are many types of attacks, and there are many risks you will encounter or you need to be aware of when using open source. Not all of the risks are related to malicious activity, but majority of them are. What is worth keeping in mind is that open source is a great way for a malicious actor to get into a company's software supply chain. No one has enough time to check all of the dependencies, read all of the code or all of the packages, track all of the version releases, track all of the maintainers, and all of the stuff that is happening in open source ecosystems. And projects usually start with the latest versions, then they fall behind, then there's this period of maintenance, upgrading, making sure it kind of stays up to date. But what is worth keeping in mind always is that part of your software supply chain risks, bigger part of the software supply chain risks are inherited from your, actually all of the supply chain risks are inherited from your dependencies. Many of them are inherited from your open source dependencies. It is worth keeping in mind that we're talking here today about open source supply chain risks, which is a subset of software supply chain risks. The risk related to outages, cryptojacking, botnets, crypto mining, data loss can happen, data leakage can happen, and there are also legal risks related to being compromised with a supply chain attack. And what is worth keeping in mind is that for NPM, PyPy, Ruby gems, and a couple others, running an install of a package is enough to make things bad. Well, possibilities are almost endless, because the moment we run npm install, we give all of the permissions of a user under which we run the install command on our system, right? So if we're doing development on, instead of a Docker, for example, we're doing it directly on our computers. When we run npm install, any of our third-party component providers, including open source component providers, gets permissions to do whatever they want on our computers. And this is being used frequently. You don't have to run the code that is using your npm open source compromised packages. You just need to run an install. And there are a couple ways in which you can countermeasure those risks. Well, the best software is the software you didn't have to write, obviously, right? The less dependencies you have, the better. But unfortunately, due to transitive dependencies, you may have only a couple, and in the end, you end up with a couple hundred of them. By the way, this person is Yoshitaka Sakurada, Minister of Cybersecurity, who recently confessed that he does not know how to use computers. He was fired later on. You can implement all of the things yourself, which is actually, as crazy as it sounds, for NPM ecosystem, quite often the complexity of underlying libraries is low enough to implement some of the functionalities by yourself. Then you get rid of an external dependency that may be a subject to a supply chain attack. Not always recommended, but I do recommend reviewing the packages from time to time and making sure that they actually provide you any value. Aside from that, there is no silver bullet. Obviously, you need to use only verified packages sources. If someone asks you to use a really weird third-party package source for their open source, then yeah, I would be a bit suspicious of that. You need to watch out for typo scoring and brand jacking. It can be a big problem. As I said, running a single npm command by accident may cause a huge problem for you and your company. So be aware of that and triple check what dependencies you define in your projects. From a legal standpoint, review the licenses of libraries you use, just to avoid legal shakedowns. Keep an eye on the health of your dependencies. That is, are all of your packages maintained? Are there any maintainers? Are the bugs being taken care of? Are the CVEs being created? Or is there any type of security reporting program? If you clearly identify packages that are being abandon them yourself, or take them over if you cannot drop their usage. Don't update on Monday. Based on last year's data, by the way, this and a lot of cool stuff is available in our threat report for NPM that we published a couple of weeks ago. I encourage you to read it because they're pretty cool stats there. And one of the things we analyzed is what is the frequency and what is the daily distribution of malicious software on NPM. Most of it happens on Friday, Saturday, and Sunday. So if you pick up stuff on Monday, there's a probability that NPM security team didn't yet get into all of the security research, all of the security notifications based on, for example, our reporting, right? So there may be still malicious packages on Monday that are there after the weekend. Don't do it on Monday, and I'm not saying you will be fine, but you minimize the risk for yourself. And also, don't use new packages. If there is this super brand new package that is 1 day or 2 days old, there is a chance that it may contain something malicious, or that it wasn't yet analyzed by anyone. It would be probably analyzed by us, but yeah. You definitely want to have critical CV notifications connected to your on-call duty setup. I'm not saying about all of them, but the ones that would affect your production systems and the ones that would actually be critical. That's always a good practice. Never install any packages without running an assessment. Make sure that what you install is actually owned by someone that it's not only the package is not only saying that it is owned, but that it is actually owned by by a legit entity behind it. Check the source code, check how the package behaves. Just make sure it's something legit, especially double check or triple check any new packages that are being introduced to your stack. It may happen, for example, when you have a transitive dependency and its dependencies are changing. It can change in between versions. Sometimes it can change even without new versions being released. But if a version is being removed, the version you depend on, and you don't have it in a cache, your system may actually ask you to re-resolve stuff. And this is maybe also a moment when a new transitive dependency may be introduced, one with some malicious content in it. Review the code changes before you upgrade. You can do it with Diffend. You can go to my.diffend.io and you can pick NPM and pick any package you want and any versions, and you're gonna get a diff. Connect if you don't have, I highly recommend using a dependency updating tool like WhiteSource Renovate. Connect it, but at the same time, make sure you have a delay. So don't set it up to always create a pull request 5 seconds after a package version has been released. Give it some time. Don't run a single env-based CI/CD pipeline. Many companies do that because it's easy injecting all of your environment variables at the beginning and having them till the end. The problem is that with malicious packages that steal environment variables, you may accidentally allow for a Docker registry credentials leakage, right? Which can allow an attacker to use that to exploit other parts of your software supply chain. So think what you actually need in a given CI/CD pipeline step and provide only this data into the particular steps. Educate your developers. You need to protect the whole development cycle. You need to shift left. You need to start from the developers' computers. Most of the time, it's them who define the dependencies. It's them who run NPM install first, and it's them who gonna be compromised first. It's actually quite interesting because we've seen some attacks where the attack wouldn't be noticed by developers that introduced the packages. It wouldn't be noticed in the CI/CD pipeline, and only it would be noticed in production. But all of the software development lifecycle steps would actually be compromised from the developers' computers to CI/CD till the production. But it all started with developers, right? Keep in mind that what you see in GitHub or GitLab or any other place where the source code is present may not be the same code as the one that is shipped in a package. There's a build process, right? If a build process of a package is compromised, the content of the package may be tampered. There were attacks where the GitHub content would seem legit, but the package content would be changed just to mislead people checking the changelog and making sure that the content is legit. You need to do it based on the package registry data. Use Defend.io. We at WhiteSource do our best to analyze packages the moment they're being released, and sometimes a bit later. That depends. We have quite sophisticated system to do that. And we pick up interesting stuff from NPM. So to sum up, trust no one. Update your dependencies only when you're sure of their content. Update one at a time, not remove the log file and just rerun it and see what will happen. Track changes in this open source you use. Be aware of the environment in which you're running the software. Run CI/CD pipeline in isolated stages. But obviously create a security flow that will match your organization. So depending on the type of the software you're building and the stuff you have on your computer, if you're not running your software development in isolation, adjust the security flow according to that. Keep in mind that there's a whole software development lifecycle, and it does not start with CI/CD. It starts with the developers picking open source components. And please give a try to WhiteSource Diffend. I think that's all for today. You can find me on Twitter. You can find us on Twitter. You can always drop me a line if you have any questions. I've seen some really interesting packages and interesting cases. I've showed you some of them. I hope you had a good time. And as always, have a nice day and stay safe.
And thank you so much, Maciej, for taking the time to join us and share your expertise. I'd like to remind our audience that today's session was recorded. If you missed any of our discussion, the link will be emailed to you so you can access the on-demand recording. You can also find it living on the DevOps website if you just visit devops.com/webinars. So quickly, we do have 4 gift cards to give away. These are for $25 Amazon gift cards. Our first winner is Pragya B. Our second winner is Stefan S. Our third winner is Scott H. And our fourth winner is Surindra M. So congratulations to the 4 of you. Please keep an eye on your inbox to claim that gift card. And if you don't see an email, just check your spam folder. I would like to thank WhiteSource for sponsoring today's webinar. And I would finally like to thank you, our audience. We really appreciate you being here with us for today's webinar. Please take a moment to fill out our post-webinar survey, and we hope to see you at a future or upcoming TechStrong Learning event.